Hello, everyone. Sorry for the delay. We ran through some technical problems. Thank you all for being here today. I will be quick with the introduction. Welcome to our cybersecurity webinar organized by New Horizons and Stefanos Evangelou. We are excited to have you joining us on this journey towards enhancing your understanding of cybersecurity. Allow me to introduce myself. My name is Kali, and I'm the Media Marketing Executive at New Horizons Greece and New Horizons Cyprus. At New Horizons, we believe in the power of knowledge and continuous growth. With 40 years of experience and having trained over 30 million individuals worldwide, we are committed to turning IT learning into real business value. We take pride in being leaders in information technology skills, project management, and leadership development training. All our courses are delivered by certified instructors who are passionate about sharing their expertise. When you participate in our programs, you can expect comprehensive educational materials, access to virtual labs for 6 months, video recordings of sessions available for 6 months, certifications of attendance. I encourage you to explore our course schedule on our websites to discover more ways we can support your career development. Thank you for being part of this webinar. Stefane, please continue.
Sorry, I was muted. Thank you very much, Kali, for the introductions. So I would like to welcome you all to this webinar today, which will talk about cybersecurity trends. This is an entry-level webinar, so it's addressing beginner audiences, but also more advanced attendees are welcome. So first of all, let me share my screen. I have prepared some presentation slides for starters, and then we will have at the very end, we'll have a quick demo session to give you some hands-on from one of the concepts that will be highlighted during our discussion. So first off, let me share my PowerPoint presentation, Kylie, just for you to confirm that you can view it.
Sure.
Should be able to see my PowerPoint, and I'll just put it in
we can.
presentation now, presentation mode. So can you see the first slide, webinar?
I can, yes.
Okay, so let me start. Again, welcome you all to the Building the Future of Cybersecurity webinar. Let me say a few things about myself. I'm a cloud architect and certified trainer. I possess technical trainer certifications as Microsoft certified trainer, CompTIA technical certified trainer, as well as CertNexus authorized instructor. You can find more information about myself and my bio in this URL if you're interested. Let me talk a little bit about the webinar itself. It's calculated to last for approximately 1 to 1.5 hours, and we're going to be having a quick Q&A session at the end, time permitting. Please remain muted during the session so that we don't have any background noises, and I will proceed through the slides, and then we'll reach the hands-on demo, and at the very end you'll have time to ask any questions you want. Also, the webinar will be recorded, and the video recording will be made available to you after the webinar. So let me present the webinar's agenda first off. As I said, this is an entry-level webinar, but it covers a quite big length and depth of, breadth of sources for you to get started with in the cybersecurity field. So first off, we're going to be talking about some fundamental cybersecurity concepts, and then we're going to be discussing the most important cybersecurity practices, taking into account the latest advancements in cybersecurity. These cover the multi-layered nature of security and the most recent paradigm, which is called zero trust and replaces the traditional architectures in cybersecurity. Also going to be discussing vulnerability scanning and penetration testing, two very hot fields that most enterprises nowadays need to address on a continuous basis. Also, we're going to be discussing the topic of security operations centers, SOCs, and this is also quite hot nowadays because given the very complex nature of cybersecurity and the multidisciplinary nature, the fact that we have to discover different types of threats and threat vectors, we need to have a very well organized operations center for managing cybersecurity assets. And last but not least, we're going to be discussing some security certifications that enterprises worldwide seek to get to enhance their overall capacity in terms of cybersecurity awareness. We're going to be having a quick demo session to explore parts of what we have discussed in the Security Operations Centers field, more specifically the software tools that SOCs utilize. And this is going to be in the form of Azure Sentinel, which is Microsoft's offering for a complete security operations center comprising all the necessary processes and tools to activate the SOC on the cloud. And then before closing, I will briefly present to you what options you have if you're beginning your career now, or if you have already a career in IT and wish to expand your knowledge and experience in cybersecurity, what would be the recommended cybersecurity technical certifications that you can look into to progress in your career. So without further ado, let us start by introducing some basic cybersecurity concepts so that we are all on the same page so that we can then progress with our discussion. First off, as I mentioned at the very beginning, what is security? Security is a multi-layer topic, a multi-layer concept. What do we mean by multi-layer? If you're familiar with the Aussie ISO certification, which basically provides a standard for standardizing the analysis of TCP/IP networks, you know that we have multiple layers on which we organize our concepts. Similarly, in security, we need to be aware that when discussing cybersecurity, we're not talking one thing. We're not talking only one field. There are various fields, one overlapping the other, that we need to be aware of. So cybersecurity in computing systems actually applies to many different areas and categories, the most important of which you can see on this slide. So think of a data room in your company or a larger data center that comprises physical installations through which you have to be authenticated in a physical manner. And then after you enter the actual data center, you have to pass through a number of checks before you can actually reach the data that is stored in any kind of available form within an application or any other system. What will be the checks and the steps that you have to go through to be authorized to access this data? So starting from the very outer level of the installation, we have what we call the physical security. And what I'm doing is on the left side, I'm providing some examples to better explain what these areas encompass. So the physical layer, some good examples would be some CCTV systems with cameras operating 24/7 in a modern cybersecurity facility, and all data centers do have that, as well as biometric checks for all facility and staff working there. Now, after you go past these checks, you'll have to, in a logical manner, be authenticated and authorized to access the rest of the infrastructure by applying some identity and access principles. One such example is a zero trust architecture. Then you will be entering even further inside the infrastructure by meeting what is called the perimeter. That is the total number of appliances and devices that constitute what is the outer part of the network. That is called the perimeter network. And some examples of systems which ensure the perimeter cybersecurity are the distributed denial of service systems. These systems actually ensure that if there is a targeted attack on a server, for example, a web server that gives certain web services, there might be targeted attacks that many users worldwide request resources from this server concurrently so that they deplete the resource of the server. So this might end up having the server not being able to accommodate the requests of legitimate users. So having systems like these, like DDoS and IDS/IPS, these are for intrusion detection systems and intrusion prevention systems, can proactively detect these kinds of intrusions and make sure that they impose some limiters on the malicious activity so that the perimeter of the network is protected. Now, if we go even deeper inside the infrastructure, we meet the actual network. And by that, we mean the layer 3 network and the layer 2 network, whatever comprises our core network infrastructure. And here we're talking about firewalls, routers, switches, and so forth. Two great examples of this layer for cybersecurity are obviously the VLANs, which is a way to segregate networks in layer 2 isolations so that specific traffic is allowed towards another specific traffic following certain rules. Same happens with firewalls, this time at the layer 3 or even layer 4 level. I'm using again the ISO OSI layer for the descriptions. Then if we go even deeper, we meet the compute world, which comprises the servers and the workstations and any other kind of compute device or service. There we have hypervisors, we have virtualization, we have virtual machines, and we have the operating systems running inside. So we do need to have some level of cybersecurity on the VM operating system level. And then we meet the applications which are running inside the operating system. We can have any kind of application, whether that be a Windows application, a Linux application, a CLI application, command line, or it might be a web-based application. Such an example is the OWASP principle. You can look it up. It's basically a standardization organization for having secure coding and proactive cybersecurity for web applications. And then last but not least, we have the actual data. So inside our applications, inside our SQL databases, etc., we have data. We have to protect this data. One such great example for cybersecurity there is encryption. So we encrypt the data as we'll see in more details later on. Now let's talk a little bit about the concepts of compliance. We need to be compliant when we're managing our data. And the three most important principles around compliance are residency, sovereignty, and privacy. Data residency relates to where the data is actually located, stored. So if now we're running Teams, for example, we might have Microsoft 365, Exchange Online, these kinds of services that run on the cloud. Where we need to know from a legal perspective and operational perspective where our data actually reside. This might be European Union or it might be outside the European Union. Some of you might know the GDPR certification standard, which actually is a legal framework mostly for making sure that the data is private. In this case, we need to know for European countries that the data have residency inside the EU. Very similar is the concept of sovereignty, which relates to the actual legal framework that is imposed on the data, where the data is stored. So if the data is stored in the EU, again, we need to query the data processor and check whether that data is actually on a server in a region in Ireland, or maybe in a region in the Netherlands, or in a region in Italy. So depending on what the physical location of the data is, the respective legal framework of that country would apply, in coordination, of course, with EU and other special regulations. And then we have data privacy, and there comes also the GDPR paradigm that I mentioned earlier. So privacy encompasses all the procedures that are related to the collection, processing, use, and sharing of personal information, and the way that the processor, the data processor, makes the object of this information, of this data, aware of how these procedures are going on. In other words, how we as consumers and end users of an application have our personal data stored and processed in a third-party system. That's part of the data privacy. Now, another quite complex topic, but we're giving just the high level of it, is identity. So when operating in an online world where cybersecurity is a very fast-paced, evolving concept, we need to be familiar with the concept of identity. So everybody, whether that be a person corresponding to a user in an operating system or in an application, or whether that be an application, or whether that be a device or something else, we have even more complex topics and concepts in this case, like a service principal in the cloud infrastructures. So any kind of such entity is regarded as an identity. So you and I, as an end user, we have an identity in a system, in the operating system, in an application. And what we use as concepts to understand the flow of traffic between the users, the applications, the devices, and the authentication systems, we have two major concepts which are called the identity providers and the service providers. So an identity provider is a server or a large infrastructure which acts as the means to impose control on the identities, the users, the applications, the devices, which are trying to access some kind of a resource in an infrastructure. This is the identity provider. The identity provider has a list of identities which are allowed to access the infrastructure, and it imposes the checks upon these identities. And after the checks are successful, then the identities are allowed, are authorized in other terms, to access resources in what is called a service provider. So a service provider is again another infrastructure which hosts the actual service that is to be consumed by the end user. As I mentioned previously, we have two major topics in the identity field, and these topics are the authentication and the authorization. What's the difference between the two? Authentication, also known as authn, is the process by which a person, user, application, device, and identity in general is able to convince the other side to prove that they are who they claim they are. This is what is called authentication. It's like presenting your, let's say, passport when you're traveling through two countries' borders. In this case, we do the authentication of the user. So I say I'm Stefanos, and I have to prove that I'm Stefanos to the identity provider. This is done by utilizing a number of authentication protocols. Some examples I provide here, which you might have heard of, is OpenID Connect, XAML, and LDAP. So by doing this process of authentication, we then go to the next step, which is authorization. But before we go there, we might need to be challenged more than once. So conventional systems, they only have a username and a password. But nowadays, this is not enough. To say that we're really secure, or to put it in a better way, to say that we have the fundamentals, the minimum security for any authentication system, we need to at least apply an additional authentication factor beyond the original password. That's why we call it 2FA, standing for two-factor authentication, or MFA, multi-factor authentication. So in the case of username and password, a password is something that you remember by heart, or you have it stored in a password manager. Then you enter an additional factor, which might be a token, a hardware token, a USB key you have on your hand, like banks used to do some time ago. Or it might be a software application that generates periodic codes, one-time passwords and tokens that you have to use on top of your original password. So this is not something you know, this is something that you have. And then if we move that one step further, we might also have biometric factors, like, for example, having to enter a very highly secure, let's say, data center. You have to use your fingerprint. So you use your password, which is something that you know, then you use another token, which is something that you have, and then you use your fingerprint, which is something that you are. So these three levels constitute what we call the multi-factor authentication. And then after we have authenticated successfully, we pass on to the phase of authorization. What does that mean? It means that we need a system that uses a protocol and an algorithm to actually authorize us to consume the services from a service provider that we mentioned earlier. In this case, we need, again, an authorization protocol for this purpose. One great example is the OAuth protocol, the latest release, which is OAuth 2. And then we have another principle which is called accounting, and has to do with how we manage users. If we combine authentication, you see I have them underlined, the first letters, authentication, authorization, and accounting. All these together combined in a management system is what we call the AAA system. AAA. AAA stands for authentication, authorization, accounting, and is an integrated system that actually manages identities in an integrated fashion. Now we go to CIA. Beyond being the famous American agency, it's also a cybersecurity principle. So it's CIA are the first letters of three words: confidentiality, integrity, and availability. And these are very important principles that pertain to any kind of data processing and related cybersecurity activity. So anytime we have to deal with data and with protecting our data, we need to make sure that the data is confidential and it is exposed to only the people who have interest in it and to no one else. Also make sure that the data is has integrity, so remains intact and is not stolen or is not tampered with, changed in any way. And last but not least, we need to make sure that data is available whenever the appropriate users need to have access to it. The data should be available to them. And now we're going to be touching another very important aspect of cybersecurity, very fundamental principle, which is called encryption. I believe that most of you have heard of the term, or maybe you're more advanced and you know more details. We're just presenting now concepts at a very basic level here. So what is encryption? Encryption is a means, is basically a procedure by which we utilize software algorithms. They might be written on a piece of hardware, that doesn't matter. At the end, everything, at the very end, everything is software. So we utilize an algorithm to change the contents of one piece of information into another so that the reader of the final output is not able to comprehend the contents of the original information when they read the output of this transformation. So an encryption is a sort of a transformation which is imposed as an algorithm on the original piece of information and produces another piece of information. And obviously this is done because we don't want the original information to be tampered with by hackers or other malicious users. And we do encryption at three levels for our data. The first level is encryption for data at rest. That means that we encrypt the data when the data is saved without any dynamic action. For example, data saved in a SQL database or data saved as files in a virtual machine and operating system level, etc. The other level is the encryption of data in transit. So we need to make sure that when we transit the data, when we transfer the data from one server to another or from a server to the end user, for example, a web application, we need to make sure that data is actually encrypted and no other user who doesn't have authentication and authorization to that service is able to capture that data and use it for malicious purposes. A very great example of that is the lock that you see on the websites and web services, which corresponds to what we call a TLS certificate. TLS is the name of the security protocol that actually performs this encryption in transit, when the data is in transit. And then when the data is actually in use, for example, when an application needs to read a SQL database, the data is encrypted at rest in the SQL database. But when it needs to be used by the application, it must be decrypted. So what happens then? Is the data vulnerable? No, because then we have a third level of protection, which is called the data in use encryption. And that ensures that the application is not actually capable of getting hold of the data, but only performing the necessary operations. And at all other times, the data is encrypted. And also, just to provide another important fact here, is that encryption algorithms, and there's a huge number of different encryption algorithms. The encryption is something that's very fast-paced. And if you've heard, for example, of the new technologies in hardware and the quantum computing, which is advancing at a very fast pace nowadays, the encryption algorithms is something that is very easily broken by malicious users and hackers. So what happens is there's a continuous rally between the malicious users trying to hack an encryption algorithm and the legitimate users and researchers trying to find new encryption algorithms to be even stronger and even more difficult to break. In general terms, though, we have two general categories of encryption algorithms, and these are the symmetric and the asymmetric. The basic difference being that in the symmetric encryption, we only use a shared key which is basically used to encrypt the information. And if we need to decrypt the information and go back to the original format of the data, we use the same key. Whereas in the asymmetric encryption, which is generally more secure, is that we have two separate keys. What we have a public and private key pair, and we use the public key to encrypt the information and the private key to decrypt it. Now, next to encryption is another very important concept that we use very frequently when doing cybersecurity operations. We don't even know it, that this is going on behind the scenes every day when we log into systems, is what is called hashing, password hashing. What is a hashing algorithm? Again, it's a transformation algorithm that takes a piece of information, piece of data, performs a transformation on it, and produces an output. That's a hashing algorithm. So what we take as an output on the right is different from what we have on the left, and it's impossible for someone to be able to predict what we have on the left without knowing what the hashing algorithm is. What we have to take into account about hashing algorithms is that they're deterministic. What does that mean? Deterministic, as opposed to stochastic, is the process by which if we apply an algorithm and a certain procedure to a certain input information on the left, if we take the same input and apply the same hashing algorithm, the output will always be the same. So that means that the output will have a unique identifier which is matched in a one-to-one manner with the source. So that means if I have two users in a system which have the same password, and I apply the same hashing algorithm to these two passwords, I'll get the same hash output. And these are called the password hashes. So I have hash 1 and hash 2. And these are going to be the same if the user passwords respectively are the same. This is why in practical terms, just hashing a password is not enough. In practical terms, what happens in systems is that when a user types a password, types their password, the receiving system gets the password and also has a saved hash of the password inside it, and it checks the generated hash of that password that the user has just given to it with the stored hash. If the stored hash and the newly generated hash are the same, then that means that the password is correct. So practically speaking, no system actually saves passwords. Systems, authentication systems, they save hashes, and they compute the hashes every time the user needs to log in and compare it to the saved hash to check if the password is correct or not. But again, if we have a very advanced malicious user and a hacker, they would be able in some cases to perform techniques to reverse engineer this procedure and be able to deduce the original password from the hash. So what we need something extra to make it stronger, and this is where salting goes in. So we do a salting of the hash to make it even stronger. Let me explain that. What is salting? As you can see on the image, we have two users with the same password. If we impose a specific hashing algorithm, in this case it's SHA 256, we get the exact same output as the hash of the passwords. So identical passwords give identical hash values, and this makes the hashes and subsequently the passwords very susceptible to being broken by a hacker. So what do we actually achieve by doing a salt? A salt is a string. It's a combination of letters, special characters, and numbers, which is randomly generated, and it is appended to the original password. So it's every time it's different. So even two users with the same password, by the salting procedure, they will have, in the end, they will have a different string to be hashed at all times. So we apply the same hashing algorithm to different strings, and what we get is we get a different hash value. So then what do? We save this hashed value, which includes the information about the salt that we included, and we also save the salt itself, the salt string itself. This is not susceptible to malicious attempts because even a hacker getting access to the salt itself is not enough for breaking the password. On the contrary, the salt enhances the overall security of the system, because now the system which actually has the hashed value saved in it, what it does is it takes the user's input, the original password that the user types in. It also takes the saved salt, it appends it to the user's password, and then it calculates the expected hash value. If that calculated value is the same as the saved hash value, then the password is correct. So as you can understand, by doing salting, we hugely increase the overall security of the system. I have to make a statement here that there's not a 100% safe and secure system nowhere, everywhere, ever. So anything that can be locked can be unlocked. That's the general motto of the cybersecurity community. That's why I said there's always a rally to make sure that we make safer and stronger systems as technologies improve. So at this point, we have covered the most important topics, fundamental aspects, and terminology of cybersecurity. So it's time to delve a little bit deeper into some of the most well-known, popular, and modern trends of cybersecurity. And I will try in this limited time to give you an overall view of topics and trends that you should be aware to make sure that you are up to date with latest advancements in the field of cybersecurity. Starting with the concept of zero trust. What is zero trust? To understand zero trust at high level, we first need to understand how traditional systems up to this point, let's say from the beginning of the advance of the TCP/IP networking back in the 60s and the ARPANET in the United States, up until the technology evolved and we got to the point where we had very modern data centers, how the internet architecture and the local network architecture evolved and what principles were applied. So let's check a more traditional and typical architecture which existed and still exists before applying zero trust. How does that look like? That's a typical network architecture of an enterprise. So before going global and before creating very global organizations, having headquarters and branch offices literally everywhere in the world, the typical example would be that a company would have a local presence, let's say within the boundaries of a single country, or in the best of scenarios, in a region. In this case, they would have a headquarters, and if the company were to be very, very large, they will have some branch offices as well. But for each of their locations, this is more or less what would resemble their network architecture. So essentially, we have the internet, which interconnects all the other individual networks, and then in between the internet and our company might exist a number of different complex WAN links. By WAN, I mean the wide area network links. That is, networks that interconnect different local networks, either at a local or a regional or a global level. For simplicity reasons, let's assume that all this is combined into what we see as the internet. And this provides the network infrastructure to interconnect the various local networks of each company, of each organization, with one another via the internet. So all this is terminated at the spot, at the place where the company has what is called a firewall. So a firewall is a hardware appliance which basically connects to the WAN, the internet, and then from the other side connects to the internal network of a company. The internal network comprises one or more routers which manage at layer 3. They manage the packets and the traffic from any source to any destination, having specific rules. Same for the firewall, which has specific static rules which instruct the traffic where it is allowed to go and where not, and where packets might be blocked. To have an additional layer of defense, what we have in this architecture, the traditional architectures, we have what we call the DMZ, the demilitarized zone. Similar to the original meaning of DMZ, An IP DMZ, a network DMZ, is basically a network zone where we place computers, servers, and applications which can be exposed to the public internet without posing a threat to the internal infrastructure. So in general terms, we group our services into DMZ services and internal backend services. Examples of DMZ services might be a public internet-facing web server, which might host, for example, our company's website, and which we need to make publicly available and accessible by any internet user. At the same time, we don't want to expose our company's private data and services, like, for example, SQL servers and SQL server clusters and applications. We might have containers, we might have hypervisors running virtual machines with our ERP systems or CRM systems, specialized applications which include financial data of the company, etc. These definitely must not be in the DMZ zone because they would be exposed to the public internet. So by having this sort of very well organized and very well structured and strictly confined entities and policies, everything seems to run smoothly because there are not so many independent variables. We know more or less that we have a single or at least 2 or 3 premises that we have to manage, and we have very well defined interconnections between these two. And we know exactly what rules to pose on the firewall, the router, the network, and have a certain security policy for all of these. Things, however, have changed over the years. So moving forward especially from the 2000 onward, we saw a huge increase, especially with the advances and the introduction of cloud computing technologies, when networks became very strong and bandwidth went very high and advanced the general capacity of traffic processing and data processing of modern TCP/IP networks, in combination with the cloud computing applications and the vast majority of devices which started to flow in the market, like, for example, tablets and mobile phones, and even the IoT devices, the Internet of Things devices. So on the left, you can see these kinds of technologies and systems which actually invaded our lives, and the technology advancements which radically changed the traditional network architecture that I presented to you earlier on. So after these advancements, the boundaries of information and of network architecture started to become vague and not so very clear as it was previously. Because at this point, when we embarked on the cloud, we automatically became members of various systems, and we might have various identities corresponding to these different actors that constitute the new architecture, which is now a decentralized application, decentralized architecture. So as opposed to the previous architecture, which is more or less centralized, now we have a decentralized application. This comprises hybrid cloud systems. By hybrid, we mean systems that have both public clouds and private clouds. And this is out of scope of this discussion, but just to simplify it, I would say that you can regard an on-premise architecture, an on-premise infrastructure as a private cloud, whereas talking about Amazon Web Services is a public cloud. In some cases, companies prefer to have some of their services running on premise and some others running on Amazon, for example. In this case, we're talking about a hybrid cloud. And again, we might have a multi-cloud because we might need a virtual machine in Amazon and another virtual machine or a storage account on Azure for XYZ reason. In this case, we have multiple clouds and we have multiple identities. So you're starting to get it and understand why it's now becoming not so much clear as it was in the past, what the boundaries are between identities, systems, applications, devices, etc. For all of these reasons, we have to present identity as the new security perimeter. And this is where zero trust comes in. In this new landscape, with identity being the security perimeter, we have to have more dynamic, more flexible, and more strict rules to organize the authentication, authorization, and management of traffic and information between our systems. In this principle of zero trust model, we apply some basic pillars which comprise identities, devices, applications, data, infrastructure, and networks. And we apply some very basic rules, which are, first of all, we have to verify everyone and everything explicitly. We assume breach. So that means that we assume that everybody's a malicious actor until they prove themselves otherwise. So it's like going to the court and saying that everybody's guilty until proved otherwise, and not vice versa. This is what the zero trust model does. It starts from the foundational principle that everybody is considered a bad actor, and it imposes and implies a set of policies which are dynamic policies and what is called adaptive policies, which take into account a list of parameters, cybersecurity parameters, that do the authentication and authorization and in a dynamic way provide access to these various entities, to the systems and applications that they need to have access to. Now, let's move on to the next topic and discuss vulnerability scanning and penetration testing. Obviously, this is a very complex matter. We're not going to go deep, just provide, again, the concepts and general principles here. What we mean by vulnerability scanning, and then we'll talk about penetration testing. Vulnerability scanning is a process by which we run an audit. We audit our infrastructure environment, and by doing this audit, we identify weaknesses, what are called vulnerabilities in technical terms, and therefore be able to understand where the weak points exist and what measures we have to take to rectify these weaknesses. So to do that, we have specialized software, and this software basically does audit at different levels of the ISO-OSI, again. So that might be network layers, it might be application layers, or it might be operating system level. At all these levels, we have specialized software, like the examples I'm providing here, like some great names are Nessus, Qualys, and OpenVAS. And some of them are also open source, so you might even be able to have this kind of system in your architecture without having a cost if you go for the community version, for example, and that be an open source system. So essentially, you install that system in your infrastructure or in your customer's infrastructure if you are a service provider and you're providing security services. You let that system run after having configured it with certain collection policies for performing the audit for all IP addresses and all systems in an infrastructure and all TCP and UDP ports, for example. And that system then has an integrated library of threat intelligence, and we'll talk about that in a minute. And it categorizes this information, it compiles reports, and it provides a user-friendly report that outlines the gaps that are identified, the vulnerabilities and the weaknesses that are identified, organized by severity levels, usually, for example, critical, high, medium, low. And then you, the company owner or the consultant, will take this report and translate it into action items for resolving the vulnerabilities. Now let's talk about penetration testing. Penetration testing, on the other hand, is something more dynamic and goes into more depth. So it's basically a simulation of a cybersecurity attack, which tries to understand the resistance that the system will have to various degrees and levels of non-legitimate actions inside the system. And we can classify penetration testing in three major categories, that being black box, white box, and gray box. By black box, we mean that the penetration tester, this is usually a company, a consulting company, which we employ, and to which we ask to run the penetration test to test the resistance of our infrastructure. If they do a black box, that means that we provide them no prior knowledge of our systems. We tell them, use your knowledge and experience and try to hack our systems without knowing anything about us. That's black box. White box is if they have full knowledge of our system. That is, we provide all internal documentation so that they know our architecture, our policies, etc. And gray box is what usually happens in practical terms is that we give them some information because that's actually what happens in the real world. A real attacker might know something about the company, but not have the full image of what's going on inside. So gray box is probably the best simulation of a real life example. And these penetration tests might be either internal only, meaning they would target testing only the internal infrastructure, or they might also be external, which would incorporate also cloud systems and an attack that would be initiated from the internet towards the internal part of the enterprise. So you can see that there are certain phases that the attacker has to go through in order to be able to get access and then conduct an analysis and report and inform the end customer of the weaknesses, again, the vulnerabilities of the infrastructure. Now, there are certain differences between the two. Obviously, both vulnerability scans and penetration tests are useful and required for all organizations who wish to be competent in cybersecurity. You can see the major difference is that mostly the vulnerability scans are usually automated, while pen tests have more manual part, and then the vulnerability scans provide the breadth, whereas the penetration tests are more in-depth. And vulnerability scans should be run every at least 1 month, while pen tests can be run in a less frequent manner. So the recommendation here for any company is to utilize both of them in a sensible manner. Also, some topics about the hacking itself. We have different types of hackers. We have what we call the white hat hackers and the black hat hackers. These are the malicious users or the ethical hackers. So white hat hacker is an ethical hacker, meaning someone who is employed to do more good than harm and be able to run a simulated test, a simulated attack, and provide the report in the form of very well organized penetration testing, resembling very well real life examples. And then we have the black hat hackers, which are the actual malicious hackers that we might hear about on the news, that they have some malicious goal to make profit out of it or create impose damage on a certain organization. And then lastly, we need to discuss some equally interesting concepts about the team that actually supports the cybersecurity team that actually supports an organization. These concepts are the blue team versus the red team. At high level, the blue team is the team which is actually doing the defensive part for cybersecurity, whereas the red team is the team that is doing what is called the offensive security, meaning that they're more proactively engaged. They're doing more hunting. They're doing more penetration testing themselves internally to dynamically improve the capacity, the cybersecurity capacity of the infrastructure while the attacks are in progress or in between attacks in a proactive manner. So in practical terms, depending on the number of people working in a cybersecurity department, inside the IT department, there might not be two different teams. It might be just one team or just one person or very small number of people in the IT or security team. But in any way, the blue team and the red team representatives should work together to produce the optimal results. Now let's talk about the security operations centers, and this is what we're going to be showing also as a quick demo later on. What is a security operations center? I believe that by now you must have a clearer image of what cybersecurity constitutes, how complex cybersecurity can be, and how fast-paced and evolving it is. So it's not just a matter of one or two people sitting behind the computer and setting policies and responding to, let's say, phishing emails, for example, or blocking phishing emails. It's not that simple. It's very, very complicated. That's why we need, in practical terms, especially big organizations, we need the security operations centers, which are centralized units which integrate and centralize the management, the monitoring, and operation of anything cybersecurity related from all these topics and areas that I have up to this point explained to you. So this is the state-of-the-art facility that constantly monitors and proactively engages against malicious actors and actions in both defensive and an offensive way, as we discussed previously. One of these players, and that's a consulting company offering SOC services, which is NIX, provides this diagram from the Gartner analyst company, stating the research that has been done in a very big number of companies worldwide. What is the state nowadays for these companies in terms of the SOC infrastructure they have? So whether they have an internal SOC, if they have a tiered SOC or a hybrid SOC, meaning they have some people in their internal team, but at the same time they employ bigger professional managed security operations center services to be able to manage all these incidents and security operations. So it's very important to have a SOC because it, as I said, it covers all these kinds of functions, the continuous monitoring, detecting threats and responding to the threats as they come in by creating what is called an incident. And the incident has all the information about the threat that is received. So what are the key components of a SOC? Obviously the people and the processes, internal processes that there might be workflows, there might be what is called playbooks, that is automated set of actions for responding to an incident. And obviously for all this to be carried out, we need specialized software, and there are different kinds of software that can be employed in a modern SOC. The most important of which are the CM, EDR, XDR, SOAR. This software does different kinds of things in terms of collecting security information, analyzing security information, creating logs, generating incidents, protecting endpoint devices, networks, emails, and also orchestrating and automating the responses of a SOC to these kinds of incidents. So all these working together with the help of threat intelligence systems, that is databases which constantly keep active information about what's going on around on the internet and what kinds of threats are active right now out there. For example, we heard about this incident, the security flaw of CrowdStrike. That's a company that provides anti-malware software, and that was incorporated as part of a Windows update quite recently. I think it was a few months ago, and that had a huge impact on devices in numerous fields and sectors worldwide, including banking, transportation. A lot of airports were closed down for very many hours just because of this release of this Windows update, which had this CrowdStrike add-on inside. So this kind of threat intelligence includes all this kind of information, what's going on at any given point on the global internet, and this is incorporated inside the SOC to better counteract any kind of attack. There are many kinds of challenges. For example, the volume of alerts, the skill of shortages. You can imagine that being able to operate a SOC requires people who are very skilled and have very hands-on and have a very deep level of experience. It's a very complex environment with mixed IT infrastructures of all kinds and sizes. And there should be some best practices to be applied to counteract these challenges, like, for example, prioritizing alerts, because you might have a huge number of alerts, continuously train personnel, and also automate things to save time of more experienced consultants, cyber security consultants, for managing difficult incidents. Now, the final part, and we're going to go very briefly through it because I don't want to spend time going into details, just very quick pass for you to be aware of what are the key certifications that a company, an organization can go for if they want to be recognized as a responsible company or organization taking cybersecurity seriously, educating their users, their administrators, and being always one step ahead in terms of tackling cybersecurity threats. Some of the most well-known ones that most companies go for in Greece and abroad are the ISO IC 27001, PCI DSS, SOC2, and the NIST Cybersecurity Framework, CSF. Depending on what field you're in, you might go for one or the other. ISO IEC is the most general one. PCI DSS is for anybody who's handling payment cards. SOC 2 is mostly for technology companies and cloud computing organizations and service providers. And NIST CSF is mostly for legal entities and for state agencies, started from the US, but has a very good reputation for the infrastructures of the state infrastructures of various other countries. So let's put a stop at this point and just give me 1 minute or two to prepare the connection to this demo. So what I'm going to be doing in the demo to just help you a little, help you better understand what you have heard so far, especially in the field of Security Operations Center, and we'll just give you a visualization of a real system and how things can work in a SOC, on a cloud-based SOC, which is called Sentinel. So Microsoft Sentinel is part of Azure. Microsoft Azure, as you know, is Microsoft public cloud services offerings. And one of these numerous services is called Microsoft Sentinel, which is a huge product, huge service. Modular service, which integrates with many other security services of Azure and other third-party vendors and basically provides a cloud-based infrastructure for using it as a security operations center. So I will have to stop the sharing and bear with me for a minute so that I can share my other screen where I have a live environment. So bear with me. Okay. Let me know if you can see my screen. You can give me some thumbs up. Okay. All right, so if everybody can see my screen, this is a demo environment of Microsoft Azure. So this is the Azure portal that you can reach by going to portal.azure.com, and that assumes that you have a running Microsoft Azure subscription. There you can create entities which are called resources. Everything inside Azure is a resource. So we have an infrastructure which comprises what is called the Microsoft Entra ID. Microsoft Entra ID is, just to put it very simply, the identity provider for Azure. And it's basically where all the authentication and authorization mechanisms that we talked about earlier reside, also where our users and groups reside for our tenant, because the different companies inside Azure are organized into various tenants. So we have a demo tenant here. This tenant has a subscription, and inside the subscription we have various services, as you can see. So if we go to Microsoft Entra ID, one of these services, we can see a list of demo users we have inside. Some of these users might be administrators, some others might be test users which don't have special permissions. And this is essentially the system where we manage, as you can see, our users, edit their properties, doing reset of their passwords, deleting users, and also viewing the audit logs. That is checking who has logged on, who has tried to log in with the wrong password, and any other kinds of events and incidents that have occurred. As you can see here, for example, I have created some test users like test003. I can see all these incidents and events at this point. That's what we call Microsoft Entra ID. Also, we have what is called Microsoft Defender for Cloud, and this is basically an integrated cybersecurity system, anti-malware system, but that's something a lot more than anti-malware because it covers every cloud component that's inside an Azure subscription. Obviously, what I'm referring to right now can be generalized for any other public cloud, but right now we're seeing concepts specific to Azure. So we have this service which is called Microsoft Defender for Cloud, and it covers all services that we might have inside our subscription, including, for example, virtual machines or SQL Server services, policies, templates, storage accounts, etc. all these kinds of cloud native resources can be protected in terms of malware protection and cybersecurity protection in more generally by Microsoft Defender for Cloud. And then what we have is a Microsoft Sentinel. Microsoft Sentinel is a system that is basically a combination of services that eventually constitute what is called Security Operations Center. But at its core, it's a CM system. And if you remember the CM word that we spoke about a while ago is the principal system that collects information and does an aggregation of logs and used for cybersecurity related information from different systems, aggregates this information, compiles it into a log, and then combines this knowledge against other threat intelligence databases to be able to respond to alerts with incidents and then respond to incidents with automated actions. We'll see more details hands-on later on. Unfortunately, we don't have the level of time, the amount of time to provide you a full working end-to-end demo. So what we're doing right now is more familiarizing with the environment and trying to apply some of the principles, as you remember, that we mentioned throughout our presentations. And these are fundamental cybersecurity principles. Then if we go inside the Sentinel resource, we see that it comprises one or more workspaces. So we have created already a workspace called Sentinel 001. Essentially, this workspace is running on top of what is called the Log Analytics workspace. A Log Analytics workspace is an entity that is actually doing all this aggregation of data and exposes then this data in a dynamic way with its own query language, which is called Custom Query Language, KQL. And then you can run any kinds of scripts very similar to the SQL language, the structured query language of SQL servers, to query this information and get some valuable insights. So this is what is running behind the scenes for Microsoft Sentinel. So if we go inside the workspace of Microsoft Sentinel, just to see what are the building blocks and the items that are related to a CM. And more generally speaking, a security operations center, such as Azure Sentinel. So as you can see here, we have various entities. Some of them are related to threat management, some others are related to content management and configuring Sentinel itself. Starting from the very beginning, I can show you, for example, the logs, and this is what I mentioned previously, that we have a logging mechanism behind Sentinel, in which we can either select one of the many available templates that are available in the Queries Hub. So the Queries Hub is basically a repository of different types of queries pertaining to applications, pertaining to audit operations, Azure Monitor, Azure Resources, Azure Virtual Desktop. All these are different types of Azure resources that we might need to query our Log Analytics workspace about. Depending on what services we have and what kinds of queries we need to run, we can use some of these pre-created queries here. Here there are some queries that I have run previously. Mostly these are simple queries related to sign-in logs, so we need to get an understanding, get hold of what have been the sign-in events of users. So I have some pre-created simple KQL scripts that we can run. For example, we can get all sign-in logs events. That is, there is a sign-in log that includes all the sign-in attempts of users. If we type in this query here, let's say fetch all sign-in logs and then pipe project these specific properties from each event. This does not perform any filtering, so if I run it, it will return all the incidents which have occurred since the beginning of time for this Sentinel resource. And you can see here, depending on what properties I have set, at the very end I have result type and result description. Generally speaking, when we get an exit code of 0, that means normal output without any warnings or issues. If we get a non-zero, that means we have an issue. And in the description, you can see here, for example, this is an invalid username or password. So if someone tries to log in and they don't remember the password and they do it for 5 times, or even worse if we have someone who is trying to break our systems and performs what is called a brute force attack. That means providing a huge number of different password combinations. Let's say, for example, thousands or even millions of password combinations within a minute. This is definitely a brute force attack. And if something like this happens, obviously we're not depending only on one operation of Sentinel to counteract it, but this would be at a very simple description. It would be a way to detect the brute force attack and employ some other methods to counteract it. So that's one very basic part is the logging itself. And we could also, similarly, we can have, let's say, some sort of a filtering instead of getting all the sign-in logs, just for you to see a little bit the syntax of these commands. We can just provide a where clause similarly to SQL and say where the result type is not equal to 0. So that means fetch anything that is not normal, everything that has an error or warning. So here we can only see the ones that are failed logins from the signing logs. Let's talk a little bit about the Content Hub. Content Hub is a very quite recent addition in Microsoft Azure Sentinel. It's basically, again, a repository of different kinds of modules which can be installed inside Sentinel. And these are actually groups of objects that provide some rules and alerts for specific scenarios. For example, if we need to monitor Microsoft Entra ID and we search for Entra ID, you see I've already have it installed. I can choose that, and as you can see here, it says this is a bundled solution that basically allows Microsoft Sentinel to ingest Microsoft Entra ID audit, sign-in, provisioning, risk events, and risky users logs using diagnostic settings. And at the same time, it's got what is called a data connector. So it connects Sentinel with the outside service, in this case being Microsoft Entra ID. You can see the number of resources here, and it says it has 366 solutions, and this list is constantly growing. So that means that for any other system, whether that be inside Azure or outside Azure, we have a central point of operation, which is called Microsoft Sentinel, a SOC, and that integrates by using data connectors to other services. And then we can also have workbooks. Workbooks are objects that help us visualize information about attacks, about logins, have a visual representation of what's going on inside the breadth and depth of our infrastructure in a visual manner. And we might also have a number of analytic rules and playbooks. We're not going to talk about playbooks at all because these are advanced concepts and are actually a set of automated actions that are triggered when something happens based on a scenario structure. So that means if I have scenario A and event A happens or event B happens, then trigger a list of events to counteract these alerts. We will, however, talk about analytic rules, and if we go to analytics, from this area here, we have the option to create rules. What kinds of rules do we have? We have the schedule query rule, the NRT, near real-time query rule, and the Microsoft Incident Creation rule. A Microsoft Incident Creation rule is a rule that actually pertains to another Microsoft security service. And here you can see a list of the most major cybersecurity related services inside Microsoft Azure. So if you want to interconnect and ingest data coming from these other cybersecurity services of Azure into our central point of monitoring, which is Sentinel, we'll do it from here. If, however, we want to make a rule that is based on some form of a logic or a rule that is based on a commonly agreed threat intelligence database, we create either a schedule query rule or a near real time. Major difference being that the NRT, which has been in preview and is now very recent, allows us to do a polling, a checking of this information, whether some situation exists or not. If the condition is true, we can check that, let's say, with a very shorter increment of time, whether that be 1 minute or 2 minutes. Whereas in the schedule query rule, we have a minimum of 5 minutes, and that can be actually a very higher level. Instead of having 5 minutes, can be hours or so. But the NRT gives us a very lower duration in time. So let's try to create a new rule and see what options we get. Obviously, we get a name for our rule. That's a test rule. And provide description, severity, whether that be high, medium, low information. And this is where the threat intelligence comes in by what is called the MITRE AT&T and CK. MITRE is one of the most major intelligence, threat intelligence organizations. And this provides a hierarchy of different types of incidents which can occur in a cybersecurity attack. Someone might try to discover our system by doing network sniffing, wireless sniffing, remote system discovery, query registry, network sniffing, you name it. It might also be initial access. That covers, for example, remote services, an internet accessible device, wireless compromise, or it can be local default accounts, trying to break a default, let's say, local Windows administrator password, for example. You see that there's a huge number of categories and hierarchies here that you can correlate your rule against and say, if that scenario happens, activate that rule and create an alert. So let's say we choose some of them, and then we set the rule logic, which is we can type in a script here using KQL, similar to the ones that I provided previously. For example, it can be an all-inclusive event that says include all sign-in attempts from users trying to perform this kind of malicious operation that we set up here in the MITRE knowledge base. So we set up the rule logic and we give the system the ability to generate an incident based on this logic that we provide here. So what we say is we need to create an incident from alerts which are triggered by this rule. If someone, for example, tries to log in maliciously to a virtual machine remotely, then trigger an incident. And an incident is an object that includes all the information gathered from the rule and from the alert, and is what the actual security consultant works on. They work on incidents to try to resolve the issues that arise from cybersecurity attacks. It's a very complex matter. That's why we cannot go into a deeper level, because that already surpasses the entry level that we try to keep for this webinar, but it gives you a very good idea of where things go and why SOCs, security operations centers, are very, very important. If you need to make some tests yourself, just letting you know that you can do that in any major public cloud, such as Microsoft Azure, by creating a trial subscription without any charge, just by using a credit or debit card, and you will be assigned some specific quota credits so that you can run these operations for I think it's 90 days and a specific number of a specific level of Azure credits or quota to use. Okay, so that gives us a general understanding of where things stand with SOCs and Microsoft Sentinel. If I now go back to my presentation, let me share my screen again. So now going back, I just want to make sure that you're aware of the basic technical certifications that you as engineers or even non-technical people who wish to expand their knowledge on the topic of cybersecurity, what are the immediate next steps if you want to look into this more seriously and start studying yourself, or maybe attend any upcoming courses related to cybersecurity. So the most important ones being, for entry level, Microsoft SC 900. So that's the security fundamentals, includes security, compliance, and identity fundamentals. It's Microsoft specific, even though it covers generic principles. It's mostly focused against Microsoft technologies. For example, Microsoft Entra ID that I mentioned earlier. You can find more details in this link. Also, we have CompTIA Security Plus. CompTIA is a great institution which has a number of vendor-neutral certifications. And also we have ISC2CC, Certified in Cybersecurity, again, a vendor-neutral one. And this organization is specialized in cybersecurity. So for someone wishing to go high up in the hierarchy and have a strict and clear cybersecurity career, maybe ISC2 is the most prestigious one because it leads to many more high-profile certifications later on. Again, it's up to you. If you're an absolute beginner, you can start with MSSC 900 or CompTIA Security Plus, and then pave your way through to the higher level certifications, maybe with ISC2. I'm also providing a few links here, which I would like to give you also in the chat window so that you have a very good, let's say, bookmark list of cybersecurity related documentation, updates, newsletters, and cybersecurity threat intelligence databases so that you have a way to keep yourself up to date and start learning more no matter what level you are at. Let me give you this information in the chat. Okay, hopefully you have all received the links. From my point, that concludes what was part of today's webinar and hopefully gave you something new. There's a lot of information, but what I try to do in this webinar is try to give you a real life understanding of what cybersecurity is about and the practical understanding that if you were to embark on such a career, or if you want to go deeper, if you're already in IT, you'll have to have the mentality that you have to be competent on many different levels and areas and always try to educate yourself with new technologies in a very fast-paced area. So that's up from me. Thank you all for attending. I'm open to any questions which you might have.
Thank you, Stefane.
I'll mute myself and let us know if you have any questions.
You're everyone free to use the chat section for your questions. Or you can raise your hand. Michael raised his hand.
Yes, I just want to ask a question because we were discussing more in terms of infrastructure or access to different network devices. How would the security, or what is the security path for software development, for securing the software applications? Or do you have any specific guidance for that? And you're muted, by the way.
Yes, thank you. Very good question. If you remember, there is a lead that I gave you during the presentation in the multi-layer security slide. If you remember, you'll see the webinar recording pertaining to secure software development, specifically for web applications. And I mentioned the example of OWASP. I definitely encourage you to look it up if you're not already aware of it. It's a very good starting point because no matter what the type of application or programming language that you're developing in, doesn't matter. So it's not tied to any specific programming language. This framework provides the fundamental principles for secure coding at all levels, starting from the level of unit tests all the way up to functional testing, to regression testing, to performance testing, and how security can have an impact on this type of tests, starting from writing fundamentally secure code, taking into account threats which might be unique to web applications. This is where a WASP is coming from. For example, SQL injections and XSS type vulnerabilities, cross-site scripting, etc. However, it has been developed over the years to be a framework now that can be a guiding principle for any type of application and any kind of developer to be able to apply certain knowledge for secure coding and secure software architecture as well, because it's not just coding, it's taking a step back and seeing the security of the software application. So similarly to the network architectures that I showed you, which are infrastructure architectures, and that's where I'm coming from. This is my field that I know better. I, however, do appreciate also that there's a similar approach for software architecture and the need for incorporating security principles inside software architectures and subsequently secure coding techniques. So I would suggest that you start from OWASP, and since this is to a very good extent that's accessible for free, you can get information and start thinking differently by studying the principles of OWASP, and then you will definitely come across to other by investigating the community and the threat intelligence communities around software development. You'll definitely discover different ones which might pertain better to your specific area. Are you a developer yourself?
I'm a product manager. I've been a
Okay.
developer, but now I'm a product manager because now there are a lot of focus on secure software development and, of course, integrating security during the development. And as you said, not only in coding, but in the application architect as well. So that's why I wanted to have, better heads around this topic, even though they're always expert in the team. But, as a product manager, you also have to have some understanding of what's happening if we are on the right track or if you're implementing the right measures for the product. So I just wanted to have this good overview of understanding of security in software development.
That's correct, and I will give you another lead, which has not been mentioned because we didn't have the time, obviously, to cover everything. Given that more and more applications are now being containerized and also moving to the cloud in the sense that they're becoming cloud native, for example, look at the Cloud Native Foundation, CNF. This is the founding organization for Kubernetes. And Kubernetes is the greatest orchestrator example for containers nowadays. So modern web developers and application developers in general, they're trying to containerize their apps, as this is one of the most modern, let's say, trends nowadays. So another couple of leads for you to check into would be to check the documentation of public clouds like Azure, might be AWS, with regards to design patterns, secure design patterns for cloud native applications. You will find a very good wealth of information there, because as I said, the trend nowadays is not to develop silos as we did in the past, but to start from the ground up to develop cloud native applications from the beginning. So by thinking cloud and having a solid understanding of the cloud, you get some design patterns and principles that pertain to the cloud and apply to cloud native applications, which can be invaluable for any kind of developer.
Thank you very much. Really appreciate it.
Do we have any other questions?
Feel free to ask if there's anything else.
I don't see any other questions.
Yeah, I guess that.
So I guess we should call it a day. Thank you very much all for attending, and hopefully that added some value to your knowledge or might have given you some motivation to pursue further either a career in cybersecurity or looking further into it, because you know you don't have to be a cybersecurity analyst. Given the complex nature and the large dependence that we have on technology, I think it's a duty that everyone has, not only IT people, but non-technical people, to educate themselves a little better onto these topics and be wiser users of technology and more vigilant in today's digital world. So again, thank you all, and hopefully see you in another webinar.
Have a great day ahead or a great night.